Howdy, this is your virtual machining instructor, CNC machining instructor, Ed Doherty, the CNC dude from the CNC Education Network, and Suncoast Technical College in sunny Sarasota, Florida, where it's 92 today and very humid as usual. It'll be like this all the way to October with an afternoon rain, but at least we can go swim it every day. I'm going to talk about G-code, basics of G-code. And we have a simple part here. And I'm going to use some Mastercam for demonstration purposes. But it's a plate that's 375 thick. It's 3 inches long. Oh, let me go here. 3 inches long, 2 inches wide, 375 thick. The 00, they should have put another 0 up here, but we can figure that out, is up in this corner. So programming wise, and the way I learned it in the 80s when we had to hand program everything, is we're going to program to the part, and we're going to use all the part dimensions. And we're going to use the power of cutter compensation to compensate. If you go to the Haas workbook, I have one right behind me there next to my simulator. There's exercises in there. One's like a linear interpolation exercise, and where they tell you plot the center of the tool. And then you go into cutter compensation, and the discussion is about using cutter compensation to your advantage to write a program just using these print coordinates, because it's a lot less math. And when you get into angles and stuff, it actually requires trigonometry. And my motto is, let's use the less math method. So in this case, we would like face mill the top. So let's say we have a 3-inch diameter face mill, and we want to start like over here somewhere. And we're going to go somewhere in the middle and go all the way across. That would be tool 1. Tool 2 would be to cut this rectangular shape. And tool 3 would be drill these holes, right? So, and this is an isometric view of the plate. All right, so I have my Mastercam on. Here's my Mastercam right here. I'm going to fit the window. Zoom up. I'm going to unzoom a little bit. Scary. All right, so these crosshairs represent the XY0. And this would apply, and I'll tell you the other, I'm rambling here, but why you want to learn G-code. Back in the 80s, we were doing, this was the only way of doing it, which when CAD-CAM came along and we were the setup guys, we could make fixes on the floor because we understood how G-code worked. Plus, we can write a quick program. Coming out of total CAD-CAM, everything works great most of the time, you know. And sometimes you don't even know if you're producing good code because you wouldn't even know what, you know. It was like my friend who's a music instructor but could not read music. And we used to joke around that he could have the music sheet upside down and he wouldn't know what he was looking at. So same thing with G-code. So it's really not that simple. We're not math whizzes when we started doing this. So to learn basic G-code is going to be a foundation of your career, because it's been this way, the FANUC G-code style, since like, well, when I started in 83, 84, and since then it really hasn't changed much, you know. Just machines get better and they add a couple more codes. And then there's some codes that were never used, so. Okay, so we got our rectangular block. I'm going to go in the isometric view right here. So there's our block. There's the top of the part. All right. So programming-wise, we're going to have material, right? I'm going to display the stock. There it is right there. It's not quite on center, but when you're doing a setup, if somebody had already programmed this, you're going to find this surface here and that surface there. Now, if you're edge finding, it'll be edge finder, and then you need to shift it an additional amount so you can cut material all the way around here. If you do not, you're going to end up with This side is not cut and this side is not cut. It'd be like the saw mark from the bandsaw blade in raw material. So you got to shift this a little bit, 25, 50 thousandths. And you got to cut it long enough so you have something on the other end. And you got to select material that's wide enough, right? Unless you're going to cut a plate, but you really don't want to do that because your saw cut may not be parallel to this edge and it might fall out of the vise. So you want to pick you want to pick the most parallel sides to clamp on. All right, and then we're using, I forget what they call this method now, when they went from manual machine to CNC. We're picking material that's taller because we're going to grip on the bottom here. And we're going to machine around it, and we flip it over. Some people call it the hat, and we're going to machine the hat off. Versus manual machining, you'd be just squaring the part up originally and then putting all the features in. So, all right, so I'm going to go back to isometric here. All right, so there's our stock, right? I'm going to turn that off. I'm going to go back to top view. Okay. So, let's turn on toolpath number 1, right? And I'm going to turn on fit and the back plot. This is back plot. This is a way to simulate. So I see our tool over here, right? So if I hit play, it goes across, right? Slowly, or whatever RPM and feed rate you've calculated. It'll cut across the top and get to the other side, right? All right, let's go to isometric view. All right, so there's our cutter there, represents the cutter. So you understand that when you come down, you need to be clear of the material. So you're gonna, this position over here is not mega important. Just needs to be like a little bit beyond the radius of the tool and a little extra, and somewhere in the middle here, so it can cut across. Let me use the quick verify. Ooh, there it is right there. I'm gonna rewind this thing. Hit my isometric and hit play. So that's where it's cutting. That's its tool path, right? Speed up a little bit. So, and then we'll talk about the first lines of code. So you gotta like go get the tool, turn the spindle on in the correct direction at the RPM. Then you gotta reposition to like this position right here, and then rapidly come down, but not all the way. And you're gonna gauge the tool height offset. And then you're going to slowly feed to the cutting level you want. In this case, it would be Z0. You're going to create Z0. And you're going to go across from here to here. So you go from this XY coordinate to this XY coordinate. Okay. Pretty simple. All right. Let's go to tool number 2. Basic end mill, right? Turn the path on, and let's see, is that on correctly? That looks like it's not compensated. Fit, and top. All right, let me go to my parameters for a minute here. What parameters? Ah, I've got control on. I want to have where. Okay. And we got to regenerate the code right there. Okay. This is the tool path we're going to take. And actually this has got a corner rounding feature. Let me get rid of that. All around corners, none. Okay. Regenerate. There we go. This is going to be pretty much what you do with manual code. We're going to, let's hit play. Where's the play button? Here we go. Hit play. I'm going to turn off the tool holder. So we just have the tool only. This is a 1/2 inch, a 375 end mill, 3/8 end mill. Okay, hit play. All right, that's where we're going to go. We're going to go, that's our path. Bink, okay. Let's look at that in ISO view. Oops, let's try ISO, all right. and replay that. So we're going down deep enough to pass the side wall here. All right, there we go. Now, if I'm doing it in CAD CAM, top. Right now I'm using wear compensation, which means it's going to put the tool in the right spot, and I don't need to say what size the tool is when I go to set it up. I just set the length only, and I leave the geometry at 0. If I use computer, it does the same thing, only you don't get cutter compensation, which means you don't have any adjustability. And if you use control, this is going to simulate exactly what you would program by hand. So, and you're going to get your cutter compensation, right? So this one is programmed. Let me hit play again. Play. And it does the same thing. Only with this code, you have to put in the size of the tool. Our machines are set up for radius geometry, so we put in, like on this one, would be 0.1875. And if you set up for diameter, you put in 0.375. So you got to declare the tool size. You're going to get your height offset, and you got to manually enter that, unless you're using the rotating and diameter probing method. So, but I would just manually enter it. It's a lot easier. Okay, and then we get drilling cycles. We'll just go over that real quick. I'm going to turn off this one and turn on that one. Pink. All right. This is giving you a preview of the drilling cycles here, but I'm going to hit play. Play. We got a spot drill. It's going to go point to point. All right. And then if you wanted to drill the hole, you just add on another cycle that's almost a duplicate of that with just a different tool number and a different, like a G83 code for peck drilling versus G81 or 2, just a spot drilling. All right, so let me go over some details here. Let's go back to, I already discussed the face mill. Let's look at this one here, but I'm going to put it back in the wear compensation, because this is the tool path where it's going to go method. So we need a, personally, I select up in the upper right corner, so it's not that important. So if this is our X0, Y0 right here, then I would call this like real simple, like X minus 1.0 and Y positive 1.0. In this case, we're, let's see, let's pull our print up here. Print. All right, here's our print, right? 3 inches. So if I went to do just like what is on the screen there, I would go to X 1.5 and somewhere up here like Y 1.0. And then I would go to this Y0 coordinate and turn on my cutter comp and go to these positions. Boom, 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 and then cross the fin and go around the corner. And then if I'm doing it around here, I call it crossing the finish line. But over here, we'll just go over here, and then we'll start up here. Actually, I think I can, I think I'm going to reprogram this so it does it the way I want it to. So geometry, selection, I'm going to rechain, and I'm going to select, where is it now? Oh, crap. It's metric. All right. Yeah, it's going to be this profile here. And I need to start at the beginning. Where the heck is that selection? Lead in and out, I think. Oh, excuse me. Midpoint. We don't do midpoint. Gotta go start over here. I'm going to regenerate. I hit top view. All right, there. That's how I usually manually program these things. And I'm going to add in a let's see, length 200. I'm going to do a 90-degree angle. So I'm going to make this. How do we do that now? Tangent, not perpendicular. It should be perpendicular. And nope, that didn't do it. Okay, I'm back. I fixed it the way I wanted to. I'm going to start in the upper right corner here. Okay, so this will be my start point, and the yellow lines actually represent the rapid moves. And I'm going to feed down to the bottom of 375 and go a little bit more and walk around this. So I'm going to hit top and let's replay this again. Hit verify and play. Oh, there we go. Goes around, round, and across the finish line and shut the compensation off. So let me backtrack this. Step back. Okay, let me zoom up a little bit here. All right, so let's call this X minus 1 and Y positive 1. That's our start position. If you follow Mark's first 9 lines, it's going to be, you got to put the position in there. Then we're going to go step by step. I'm going to do a little angle here. All right, comes down, and now we're at cutting depth. That's going to be a G1 move to go down. This one here is the move you need to turn on cutter compensation. So as you're approaching Y0, which is here, you're going to say, in this case, this is tool 2, you're going to say, turn on the cutter compensation value that I have in the tool offset page. But I'm using Y0 as the coordinate. If I did not do that, this tool would be right over the middle of this, and this would be way too small. Let's go to the next step. Then I'm going to say, go to this corner coordinate, which is X3 and Y0. Right there. But in reality, it's at X, I wish I put a half-inch end mill here. I could probably change it. It's 3 inches plus 1875, 3.187. That's where it actually ends up, because it's taking this coordinate and adding it to it. And as we're going in here, we're using G41, and we always use G41 because we always want to climb mill. Left is climb milling side. We rarely use G42. It's going to compensate. Even when you're coming in this tray, it's looking ahead. It's looking ahead. It's like a Swami. So, okay. And I'm going to go down here, and up here, and cross the finish line. We made a nice rectangle. And then we have to shut the compensation off. And that's this last move. And I just go back to the same position. It's pretty basic. Okay. And then the drill cycle. I'm going to turn off this tool path and turn on this one. All right. Let's go back to simulation, backplot. And this is a 90-degree tool. Typical spotting drill for your soft metals. All right, how deep do we go? You know, if you have the little Haas mini book that they give you, like there's actually a page in there that you can do quick calculations of like 82 degrees or 90 degrees or 118 degrees. How, you know, that's for your normal drills. But a 90-degree tool is a pretty typical spotting drill, they call it. And a lot of us like to get the spotting drill to spot and leave us a little chamfer, so we don't have to come back with a chamfering tool. But you're prepping to run the big drill through it. So how deep do you go? 90 degree is actually pretty simple. It's if this hole was 250 diameter, according to the print, right? I don't know what size they are on there, but I think I looked it up. It was 250. Then it's actually not even the it's the Pythagorean theorem, but it's half as deep as it is wide. That's going to be your Z. And if you're calling the top Z0, to make this 250 wide, you would go 125 deep. That would be your Z. All right, hit play. Let me leave the verify on. Oh, I guess it doesn't do it now. One step at a time. So this would be your CAN cycle, we call. Literally in the background, it's running G1s and G0s, and you can literally program it longhand. I think back in the late 70s, they were doing it like that before they came up with the CAN cycle. If you want a history lesson, but so it would rapidly go to position, and then it would, if it's up here, you might rapidly go to just above it, which is an R level. And then you feed to the depth you want, and then you got to decide where you're going to return to. That's the G98, 99. And if you watch the video with the carbide end mill that breaks, drill that breaks. If you need to return high, you would need, that would be the initial position, and that would be G98. If you say G99, it's going to return to the R position if they're different, you know. So normally, especially if you want to jump over clamps, but if you use G98, it's always the safer selection. And you can figure out how to save time later. Okay. Manual G code, right? Here we are. So if I would, you got to put a % sign up here. And then you got to give it a program number, the FANUC format program number. You get letter O in, I don't know, 1, 2, 3, 4. I come from the 4-digit era, and now they're 5 digits. So you could literally just put 1, and it's going to be 00001. So, and I get in the habit of putting my name on the top, and say STC1 Ed D. So because if we're in class, we might all be using the same program number, and I don't know whose is whose. Besides, I want to know what the project is. So I might call this the Immerse to Learn 1, right? Okay. So it's in the control. You can see right in the library. All right. First line. And let me bring up my Haas workbook. Haas workbook in my library here. Good reference material. A good trick I used a long time ago was, it is the mark first 9 lines right here. Right there. Sample of code. Sample of code, right? I used to keep like examples of the code in my toolbox, especially on machines I did not run that often, because I'd say, oh, I would look at it and so, oh, I remember how this goes. So here we go. We got some samples of code here. It's a great book. Get past the X and Y's. All right, up here. So here's a sample of code right here. And there's a bigger one up here. This is like sample of the first couple of lines. Tool change, position move, turn the spindle on, and turn on the height offset. These are all standards. It doesn't matter if you use T1 M6 or M6 T1. It reads the whole line. It doesn't do the line in order. And this one's got the position and then turn the spindle on. So it all works, you know, it'll all work. All right, so I call that the gazinta, you know, to get over in gazinta. And then you got to do something and then get out of there. So, all right, so I use these examples right here. So you notice it says % sign, program number, and name, and then write some code, right? So that's what I'm going to do right here. Notepad, all computers have it. So if you're doing this and you're running it in the simulator or you're running in a real machine, you know, and this applies to other machines also, FANUC-based machines. Okay, so typically I was taught to use a safety line. And I guess it's not that important anymore. But let's get into the basics of G code, right? I leave my cap lock on. Oh, I hit tab by mistake. All right, I hit tab again. Crap. All right. G00. Put it in rapid mode. G17. That means all the arcs will be in the XY plane. G40. Shut off any cutter compensation. G80. Shut off any drill cycles. G90. And that is putting it into absolute positioning mode, which is going to be your dominant positioning method. All right, now what? Let's get a tool. Tool 1, M6. And you learn after a while how to do shortcuts. That T01 and T1 and M06 and M6 are the same thing. In this case, you don't need to type in the what we call the end of block of the semicolon. You don't need to do that. Okay. Now, we got a tool. We got to go somewhere. Or maybe we'll just turn it on. M3 S2500. All right. Now it's spinning. Now we need to go somewhere, right? We got our print. Where's our print here? Print. Print. All right, print. Code. My print right here. So if it's a complicated part, I would take the paper and I would write down all the coordinates here. And then when I go to write the program, I'm just reading the coordinates off. All right, I'm going to use my upper left method. So I get in the habit of doing G00, G90, G54. Get in the habits on every tool change. X minus 1.0 and Y 1.0. All right, I'm in position. Now I need to get the tool down there with the correct height offset. G43, nobody uses G44 anymore. It's H01 for the height offset 1 that aligns the tool 1. And where are we going? Personally, I like to go to Z1.0. All right. So it's going to engage the height offset and it's going to rapidly move because G00 is considered to be modal. And once it's in that mode, positioning mode, it'll do everything rapidly. And it's going to do it with the G43. All right. Now we get the tool down there. Then we go, I need coolant. Turn the coolant on. M8 or M08. Now what? Now we need to do something. We got to go to the depth of this thing. So I'm going to go G01, I'm going to change modes, and I'm going to go Z minus, and just for learning purposes, as Titan would say, I'm going to put it to the depth of the wall. Usually I added 10 thousandths to that. And I got to pick feed rate. So you got to have this all stuff pre-figured out. I figured out I'm going to go 10 inches a minute, even though it's not cutting anything, but you got to have a feed rate. You don't want to rapidly go down to something that's scary. All right. Now, this is going to be our go to Y0 compensation move, like I demonstrated. Okay. So it's going to be G41. We're still in G1 mode, so you don't have to type it. You can if you want. More typing, especially if you have to control like this. So, and you're going to say, which offset am I using? I'm using diameter offset 1. Okay. Where am I going? Y0 or 0.0. They all work. And maybe I want that to be a faster feed rate. Maybe I want this one to be like 50. Speed things up, not cutting anything. All right, so now I just need to go to my print parts. I'm at Y0 up here somewhere. I'm going to go to X 3.0, Y negative, what the heck is this one here? 2.0. And I'm going to go across the finish line. So I think I'm going to go all the way up to Y 1.0. Across the finish line. And now I have to shut the compensation off. So I'm going to say G40. I'm still in G1 mode, by the way. And I'm going to go to X minus 1.0. Right? Comp is off. Now I need to get out of town, which means what am I going to do next? I'm going to wrap it up to where I started from, right there. Make it consistent. I'm in rapid mode. I'm going to Z 1.0. I'm up. Shut the coolant off. M09. Go home. The older go home command was G91, G28Z0. And you might see some funny haha shirts about that. Oh, sorry, I wrote that wrong. G28. Right. The newer one, and I'm going to put in parentheses, anything you put in parentheses is considered to be a comment and not readable by the machine, just readable by us. G53Z0. G53 means we're switching from the work coordinate positioning system to the machine coordinate positioning system, which happens to be all the way up. So either one of these works. You can type it in either way, or whatever shop you're at. You want to get in tune with how they're programming them. And also, here's another thing on comments. Maybe I put face mill here, so I know what the heck tool it is, right? 3.0 face. No, that's the end mill. Sorry. 0.375 end mill. Okay. No. 7.5. All right, tool is up, and if I'm just doing just this alone with no face mill and no, I would like the table to come to me, which is Y0 home position, G91, G28, Y0, only necessary at the end of the program, not anywhere in the middle, and then we got to shut everything off with M30. It's actually, the code is from the paper tape days. Here's another history lesson of reset and rewind. The tape would actually rewind and go back to the beginning. In this case, it just automatically goes to the beginning. The older code was M2, and that was end of program, and it would just stay right here. So, not used anymore. And we got to put a % sign at the end. So that's the end. And then I'm going to hit File Save As, and I got to give it a name. And a Haas machine can read text files. It took me a couple of years to figure that out. So I want to name the file. You can actually literally name the file differently, like a different number than what's in there. Probably not a good habit. So you can give it a name, or you can give it a program number. Program number, if you're trying to keep these things, you got to have better records. But in this case, I'm just going to call it program number. So I'm going to call it caps lock on 01234 text, right? Save. And if I turn on my NC viewer, this is an online NC viewer right here. It's an online simulator right here, an isometric view, open file, go and find it. Where's my, there it is, 1, 2, 3, 4. Open, there's my program right there, and I can look at it and see if it's correct. And, ooh, it looks like it ain't correct. Okay, let's go to top view. What is wrong with that picture? Maybe we'll have to fix it. All right, hit play. Let's go step by step. Step 1, let me zoom up here. Oh, let me go ISO. Now, if we're using a Haas simulator to just do some training on, you run the graphics mode, and it gets you this kind of view. It won't give you the isometric view, it gives it the top view. All right, is this step by step, step by step? Oh, let me rewind it. Back to the beginning. Okay. 2, 3, 4, 5. All right. All right. 375, Y0, X3, Y-2, and oh, I missed an X move. I went back and forth. Let's fix the code. Right here. See, X, Y, Y. I missed one. I need to go to X0. I think that's all I need to do to fix it. File, save. You'd be at the machine, or if you did in the simulator, you could fix it in the machine. In this, I'm going to just reload it. All right, I'll reload it. Oh, look at that. Fixed. Actually, I'm glad I made a mistake. I'm not perfect. You can fix things. Learning how to fix things is going to pay dividends in your life. Alright, so we go step by step, inch by inch. Alright. I'm going to start there. That's my start position. Comp on. Go to here, go to here, go to here, go to there. Done. Shut the compensation off. Get out of town. Done. Okay. I'm going to do part 2 on the drilling cycle and the Facebook cycle, but that's a real basic G-code lesson in my kind of style there. Oops, turning the wrong things on. So using this kind of simulation, we're doing the same thing. Let me put it back to, let's see, toolpath on, toolpath on, here we go. And simulate, backplot, and go. So you're writing to the coordinates of the part, and you're telling the machine what size the tool is. I'll get in, and later on I'll also get into the benefits of why you would want to do it that way, and tricks I use to do roughing and finishing using the same program. Thanks. See ya.